Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 21 in our incredible new tutorial series where you're going to learn Fusion 360 or you're going to die trying. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And I have a very, very exciting lesson for you today, because what we're going to be looking at is I'm going to be showing you the highest impact, lowest cost upgrade for your Creality Ender 3 version 2 printer, or really, in fact, for any printer, for any 3D printer. I'm going to show you the lowest cost and the highest impact upgrade to your printer. Good news is it costs 20 bucks, probably between 10 and 15 bucks. And I promise you that this is probably the simplest thing that you can do to most drastically improve the print quality and the reliability of your printer. Sound exciting? I hope so. So what I'll be doing is we've been going through 20 lessons, and mainly we've been focusing on the Fusion 360 side of things, but really this is about Fusion 360 being used with the 3D printer. So I'm going to be spending a couple of lessons now sort of tweaking and tuning and improving our 3D printer. The stuff that I will be talking about where I'm focusing specifically on the printer that I'm using, which I recommended you guys get, the Creality Ender 3 version 2 printer. But really the things I'm talking about I think are generically true for most 3D printers. So if you guys have a different printer, hang with me, because the things I'm showing you are going to be true for all of them. Okay, upgrading the printer. Let's talk about what the typical scenario is for most people who get a 3D printer. I know it certainly was for me. My first 3D printer was, oh my, I don't know if it was 5 or 6 or 7 years ago, but I got the MakerBot 3D printer, and I'll never forget taking that thing out of the box and plugging it in and looking at the quick start guide, putting the filament in, and then on the SD card they had this little test print of a nut and a bolt, and I can remember pressing that print button and just the magic of watching that 3D printer, and it printed a perfect nut and bolt, and you take it off and it was just perfectly smooth on all the sides and it worked perfectly. It was like taking a hit off of a crack pipe. Well, I've never taken a hit off of a crack pipe. Really, I've never used any illicit drug at all ever in my life. But it's what I would imagine taking a hit off of a crack pipe would be. It was just absolutely, positively a wonderful experience seeing this 3D object creating itself out of this filament. Okay, now that's where it got started. Then I printed a few more things, and then I began to have some problems with things not adhering to the print bed. And then I started having problems of stringers as I was trying to print. And then I started having more and more problems. And as I was going, I was printing more and more complicated things. That's true. But then finally, it got to where I couldn't print anything. And then finally, I just came back to the original nut and bolt, and I couldn't even print that anymore. And then you go down the path of trying to upgrade your printer. You want things to stick better, so you buy an expensive glass plate, and then still they're not sticking good. So then you start spraying hairspray on it, and then you start buying all this different stuff, and then finally you just throw your printer into the abandoned project corner of the shop. Okay, I'm going to tell you what I think many times the real problem is, and I might go so far as to say 90% of the time, if your print quality is degrading, it's not that you need to go out and start getting an auto leveler for your bed or buy a better print bed or all that sort of stuff. I think 90% of the time when you're having issues with print quality, the fundamental problem is a damaged or worn extruder nozzle. Okay, what's the good news? These nozzles are very cheap, and in a minute I'll show you the nozzles, the replacement nozzles that I'm using. But let me just say that let me just say that I'm going to spend a little time here with you, sort of testing out this theory of, could it be that a lot of our problems in 3D printing are really related to damage to our nozzle? And I know for my original MakerBot that was what the problem was, and for some of my some of my 3D printers between that one and the one I have now, often that was the problem. And so I'm going to kind of deep dive into that in today's video. Does that sound good? Maybe you guys are skeptical because maybe you would think that the print nozzle would not really have anything to do, would not be related to print adhesion or something like that. But let's jump in and see if we can go through this. I will get out of your way here. Let me give you a little shot of my studio setup and what we're going to be looking at today. And what I'll show you is I have to be honest with you, I have always in engineering been a real metrology guy. That is, if you really want to understand what's going on, you don't want to guess, you want to do what? Metrology. What is metrology? Metrology is the science and the technology of making measurements. And so if I want to improve the performance of my printer, I need to be doing measurements so that I quantitatively understand what's going on. And so I bought this little microscope, this little USB microscope off of Amazon. I'll be honest with you, I probably bought 7 different models of these inexpensive little microscopes, and this was by far the best one. It wasn't the most expensive one, it wasn't the cheapest one. I think it came in around $70, and man, it really is a high performance microscope. If you're interested in doing the types of metrology that I'm going to show you today, I've got a link over to this microscope down in the description below. But don't worry, if you don't have the resources to get it, you can just benefit by watching me use mine. You can just kind of believe me in the conclusion. And then the good news is a pack of something like 20 of these little extruder nozzles is something like $15, and I'll show you the ones that I'm using that I've had really good luck with. And so here's our little microscope. And so what I did was I printed probably 15 or 20 different prints recently on my Creality Ender printer, and I started getting problems particularly with adhesion of the first layer to the print bed. So I started doing all the things you're supposed to do. I washed the print bed. I leveled it as carefully as I could. I realigned my printer to get everything aligned properly, and still I couldn't get that first layer to stick well, and I was having, beyond the first layer, various quality issues in my in my prints. So what my hypothesis is that it's related to a worn or damaged extruder nozzle. So let's see. And what I'm going to do here, I have a new studio shot for you. You can see the microscope here. And now on top of this most excellent shot, I will be bringing in a live view from this little microscope. Okay, so what are we looking at here? We are looking at over on the right the extruder nozzle that I just took off of the printer, and on the left what we are looking at is a brand new nozzle right out of the little packet of nozzles. And wow, what do you see when we look at this? If you look, this nozzle on the right, the first thing that I see is that the tip of the nozzle has been worn down, when you compare it to the new one on the left. The one on the right, the nozzle tip has been worn down. Now, the neat thing about the microscope, it comes with this little transparent gauge, and so you can see that I have the nozzle sitting on top of a measurement gauge, and to normalize you, each mark on that measurement gauge is 0.1 millimeters. 0.1 millimeters, for comparison, is 100 microns. That would sort of be 10 red blood cells side by side. So you could fit 10 red blood cells side by side between two adjacent tick marks on this scale. And so what you can see is that when I look at this, it looks to me like that nozzle that I was using had about 0.2 millimeters, that's 200 microns, of the tip of the nozzle worn off. Okay, the tip of the nozzle has been worn down. Now, how could that possibly happen? Well, I think for my case, there's probably three possibilities. One is, at one point, I didn't zero things correctly before I started my print. And it just drug that nozzle very deep and heavy against the print bed, and in fact, it left a little scour mark on my print bed as well. But that very well could have been part of my problem. The second thing that could be part of my problem, I think that happens to all of us, right? That every once in a while we aren't paying attention and that happens. The second thing that happened, and this might happen to you as well, but as I go in and I try to level my print bed, what I find is that the print bed itself is not actually completely flat. And what I find is my print bed, instead of being perfectly flat, it's kind of bowed and it's low in the middle. And I'm not sure if it's like this or some combination of a bowl shape, but it is low in the middle. And so what that means is that if I get the distance between the nozzle and the print head at the four corners, it's perfect here, it's perfect here, it's perfect here, and it's perfect here. But then when I go to print in the middle, the gap is too big and I don't get adhesion. Okay, so what do I do to fix that? Well, I get it too close here, too close here, too close here, too close here, where the nozzle is almost touching the print bed in those four locations. And then when it goes to print in the middle, it's about right. So I'm kind of compensating for the lack of flatness, the lack of perfect flatness in the bed. Well, what does that mean? As it's dragging over there to get to the print area, you're dragging the nozzle across the print bed. It's actually touching in that area. And that's one of the things that can, the things that can happen, I think, that can kind of wear down or damage the tip of your nozzle. And then finally, the third thing is that we know that when we go in to level that print bed, we know that we want the end of the nozzle to be perfectly clean. We don't want a little nub of filament to be coming out. So oftentimes we come in with something like the tweezers, and we go in with the tweezers underneath the nozzle and try to kind of grab that little piece of filament that's there. And typically what we're doing is we're not just grabbing the filament, but we're sort of grabbing the tip of the nozzle and squeezing, and then the tweezers sort of slide down the tip of the nozzle, and then it kind of grabs or knocks off that little piece of filament. Or, I'll be perfectly honest, what I was kind of doing for a little while, which I found was very good, is I could bring these little clippers that came with the Creality printer, and I would bring those up under the nozzle, and then I would kind of clip. And then as I would kind of clip, those blades on the clippers would sort of slide down the brass, and then would clip off that little bit of filament that was coming out of the nozzle. So some combination of those three things led to the problem that we are seeing here, and that is a damaged nozzle, and that damaged nozzle then leading to failed prints. Okay, now you might say, well, don't touch it with anything metal. I think that's a good thing that I've learned here, but that is not the only thing. It's not that I just might have sort of been clipping off the tip of the nozzle, but I think what I do now is I don't put anything metal against the nozzle to clean it, because what you've got to see is you've got to see that the nozzle is made of brass, and brass is a very soft metal. It's one of the softest metals that you're going to run into. So any other metal that you touch that brass with, you're going to very slightly deform or change the shape of the brass. And so you've got to treat this brass tip as something very, very fragile and very malleable, and something that's very, very easy to deform. So you want to be very careful about touching anything hard against the nozzle. Okay, so let's see if I can come over here and let's see if we can look at this a little bit more. Now, again, I'm telling you, the bottom line is you need to have a pack of extra nozzles, and what I would suggest is, and what I do is, I swap the nozzles about every 10 or 15 prints, whether they need it or not. And then I like to come in and kind of inspect the old nozzle under the microscope and see, okay, am I changing it too quickly? Am I not changing it quickly enough? And sort of keep track of the degradation of the nozzle as a function of how many things that I printed. But very clearly here, very clearly, you can see that we have just worn down the tip of that, extruder nozzle. Okay, now what we can also do is we can try to get a closer look. And the way that with this microscope, the way that you change the magnification is, first of all, I'm going to bring the microscope. This is not focused. This is it's a strange combination of these two knobs allow you to change the magnification. But I am bringing the head of the microscope down much closer to the nozzles, and I'm going to lock it in there. And then with it there, now I can focus with this orange knob. But now you can see that I am focusing at a much higher magnification. Okay, now what I see at this higher magnification now is that not only is that tip of the nozzle worn down, it looks like it's worn down unevenly, that the nozzle is actually kind of cocked at an angle. The tip is not perpendicular to the axis of the nozzle itself. And so I can just really see that that's a problem. Now what I want to do is I want to kind of look down into the nozzles and see if I can learn anything else by looking down into the nozzles from the top. And so with a little luck, it's always kind of hard to do live microscopy on a video, but if I can get these things to stand up beside each other, okay, if those will just stay where they are there. Okay, now let's see if I can focus this thing. I believe we're going to be able to do that. Okay, now look at that on the left. Look at that. Absolutely beautiful. Do you see how perfectly round it is, how perfectly flat it is? Now let's look at the used one. Oh my goodness. Look at this mess on that. Is there any surprise that this thing wasn't printing good? And so let me see if I can bring that magnification up a little bit. Now let's see if we can come down and if we can zoom in on that. I want to see if I can zoom in on that. Now let's see if we can get the focus. Oh, wow. Let's come in a little bit closer. Wow. Okay. Ow. Is there any surprise? Is there any surprise that this thing wasn't printing good? And if you just look at it with your naked eye, it does not look that bad. It does not look that bad with your naked eye. Let's see if we can get a little bit closer here. There we go. Let me see if I can get that under there now. It is hard. There it is. Now I just need to focus it there. Wow. So what you can see is that you can see the extruder hole. You can see the hole is no longer round, and you can see that the brass, not only is the top of the brass worn down, but it looks like the edges of the brass, instead of being straight up and down, it looks like that they have become bent over so that you have a little lip like this that you're trying to extrude through. And that really, really, really is a mess. I'm trying to see if I can get a closer view of that. Give me just a second here. Let's come back this way. Wow. Okay. And what I believe I'm also seeing is, I believe that I'm seeing some carbonation of the filament around the inside wall of the extruder. And I think maybe if I turn this over and look from the other side, I might be able to see that better. And so let's see if I can focus back this way a little bit. And what I want to look at is, I want to look at the underside now, and I want to look for signs of a clog or a partial clog. And my goodness, look at that. Okay, look at what we have going on here. All right. Now, what I'll say is that orange region, I'm not worried about that orange region, because that orange region, what that is that's just melted filament that was left in there. Okay, that is just melted filament that was left in there. But around the orange, you can see that black all the way around on the inside. That is carbonized or burnt filament. And that carbonized or burnt filament, it's not going to melt and go away. So this is partially clogged. Now what you can see is there is still a hole. So you would be able to still extrude through this. You would be able to extrude through it, but it's like the filament doesn't want to go through because the hole's not big enough, and you're having to work hard to try to force that filament through a hole which is too small. The hole is too small. And now let's see, I really want to try to see it from this way. Okay, I think you can almost see the same thing here. Let's see if we can bring this down and zoom it in. Just taking my time to try to show you. I can see it in person better than you're able to see it on the screen. Okay, but do you see inside that, do you see that that hole is not round? The extrusion hole is not round, it's oblong. And then I hope you can also see that carbonation around the inside of that extruder. So man, when I look at this, there is just absolutely no surprise that this thing wasn't printing. And this then can begin to, this effect of a damaged extruder nozzle or a partially clogged extruder nozzle can cause other print problems with your printer. And one of the other problems it can cause is, you can imagine that this hole now is effectively, it's like a high friction hole because you've got all this crud on the inside instead of just a smooth brass wall. You're trying to push through this crud. And then besides that, you've got the hole is too small, so you're going to be having trouble jamming that filament down through this nozzle tip. And what that also is going to do then, if we come back to just the view of the printer, over here, this drive mechanism, you've got the stepper motor, and then you've got that little geared, you've got that little toothed gear that is driving the filament. That toothed gear is going to begin to slip on the filament because it can't drive it. It's turning the right speed, but it can't drive it, so you start getting slippage there. And you can imagine that that slippage is going to cause problems with your print. And then that slippage, what you're doing is you're grinding those teeth, those driver teeth, on that little gear. You're grinding them on the filament, and what is that going to do? That's going to start wearing down those teeth, and so you're going to start damaging that little drive mechanism inside of your motor here if you continue to try to work with these partially clogged nozzles. So you get bad prints, and you can then start generating problems with the other parts of your printer. So what is my conclusion from all of this? My conclusion is that we need to be diligent about maintaining the quality of our nozzle, of our extruder, and we need to not be afraid of replacing the nozzle every 10 or 15 prints. And I want to come back and show these to you again side by side, if I can get it back over there to that view. And then we'll talk a little bit about okay, and there they are. There they are again, side by side. Okay, so we talked about different ways that you can damage. It's very easy to damage the tip. How do we get the partial clogs? Well, I just think over time you can start having that carbonization build up. But I think the number one way that you get the clog or the partial clog is that if you try to do a long print and you leave the printer unattended, and then for some reason the print comes loose from your build plate, and then you do one of those air prints or spaghetti prints where you just end up with a big mess of spaghetti underneath the print head when you come in the morning, or you come in and there's just a big glob. Usually what happens somewhere along that process is you actually grind down the filament where it isn't being driven anymore, and you've got filament that's in your hot end, and that filament just sits there very, very hot, and then it becomes carbonized, and it causes this this effect that you're seeing here under the microscope. Now you know that the printer comes with these little needles, or that's probably making an ugly loud noise. These little pins that you can use to clean the nozzle. Guys, I want to tell you, you see this little pin? Before I took this old nozzle off, I had cleaned it with this pin. And yes, I could get the pin to pass through the nozzle. But even after doing that, and I did it hot, even after doing that, what do I have? Well, I have a partially clogged nozzle. Yes, there is a hole that goes through it, but you can see that it would be very hard to get your filament to go through here. Okay, guys, I hope that I haven't bored you with talking about this, but what I would like to encourage you is, number one, I'd like to encourage you to think about metrology, and if you have the resources, these little microscopes are very, very handy, and I use it not just to look at things like the components, like the nozzles. I also like to use it to look at the print quality. So, you know, I can put 3D printed parts under here and inspect them and sort of see how my walls are looking, and sort of look for the overall quality of the print using that. But the main thing is that you get a pack of these nozzles. Like I said, the nozzles are, I think it's like 20 nozzles for $15, something like that. Maybe it's $10. And this is the kit that I've linked to. I bought several different kits. The reason I like this one is it comes with the 20 nozzles. You can get them that have different size nozzles, different hole diameters. But I just get the standard 0.4 in a pack of 20. Then the other nice thing is it's got this set of those little cleaning rods so that you've got extras, and the little test tube is also very nice to store those in. But one of the things I like best about the kit, maybe I should put it down here where you can see it. One of the things that I like best about this kit is that it has this little socket wrench for taking the nozzle off and putting it back on. And this little wrench that came with the Creality ender. The first time I used it, it just rounded. You know, like I said, the brass is very soft, and this is a very thin wrench, and so it just rounded that that nut where I couldn't get it off. And finally, the first one that I took off, I just had to get off with a brute force pair of pliers, and I was able to get it off. Of course, that completely ruins it. But this little wrench I found didn't work very well, but this little socket one works really nicely. So I found this kit to be very, very effective. And what I do, like I say, is every 10 or 15 prints, I put in a new nozzle. And it, my friend, has been the difference between night and day in my print quality. And a lot of my problems went away. My bed adhesion problem went away. My stringer problem went away. And my sort of uneven feed of not getting just really smooth and uniform prints, that went away, all by doing this one simple thing. So I think that I am not exaggerating, that if there was one upgrade to do to your printer, I would suggest just buying a pack of spare extruder nozzles. And I think that what we typically do, though, is we typically try to correct for a clogged, damaged, or partially clogged nozzle by going out and spending a lot of money on the printer when the problem isn't really the print bed, and the problem isn't really that you need an auto leveler or any of that type of thing. The problem is that you don't have a pristine print nozzle. Okay, guys, I hope this hasn't been a boring lesson to you. I hope you guys will kind of get a discussion going down in the comments. Hopefully you've been chiming in on the live chat. But what I'd like to do is I'd like to get you guys to go ahead and order some of these and then have them ready and take your print qualities up. And if it's okay with you guys, I'd like to do another lesson or two on just improving the printer with some very, very low cost investments. In fact, the next video that I'll do, there's an upgrade that you can do for free that really I've seen has made a big difference for me as well. And so if it's okay with you guys, let me do another couple of lessons on improving our print skills. And then after we have a couple of lessons on improving our print skills and improving our printer, then we'll come back and we'll improve our design skills again on the Fusion 360. So give me some feedback down in the comments. Let me know if that sounds okay to you. All right, guys, I hope you're having as much fun with Fusion 360 and your 3D printer as I am. My printer is running virtually 24 hours a day. I am really in there running this thing all the time. You know, also that just reminds me, you know, the filament is kind of expensive, man. So if you look at what the cost of wasted filament from failed prints, the cost of these extra extruders is really, really very small. A new extruder is a lot more affordable than a lot of failed prints and wasted filament. Okay, guys, we're having a lot of fun here. Make sure you like this video, leave a comment down below. If you haven't already, subscribe to the channel. Those things will all help me with the old YouTube juice. And by doing those things, more people will be given the opportunity to watch this video. And I think that's important because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.